Welcome again to another episode of the Sustainability Podcast. Today, my guest is Sergio Lazzarotto of DLMS. Sergio, welcome. How are you today?
Fine, thank you, and really appreciate to be your guest today.
Well, it's great to have you. Sergio and I met briefly at the Distributech conference in Orlando a few weeks ago. We had a very substantive conversation there about energy, the grid, interoperability, and standards. So, Sergio, can you tell us just a little bit about yourself and your organization?
Sure. So, I am an electronic engineer, so I'm coming from that side, from that experience. And across my career, I have spent a substantial amount of time in the computer industry. Therefore, my background is essentially on the IT side, mainly on the PC. And over the time, I have been moving more towards, from engineering development and towards innovation management. And in the last 20 years, I've been spending more time in collaborating and working into the innovation management consulting areas, helping several organizations to implement innovation management processes, and in fine, ending up into DLMS User Association. So a DLMS User Association is a private organization, and it's a standardization organization. By analogy, is the equivalent of the Bluetooth SIG that is very well known. So basically, the essence of DLMS and the reason why DLMS was created, it goes back to the late 90s and early 2000 when the European Parliament, they voted the Directive 441, which was basically a legislative framework which was basically pushing for the deployment and the upgrading of the grid, the European grid in the different countries to adopt smart metering. And the consequence of this legislative decision was that it required, let me say in a way or in another, an answer from the industry side. And this is how, at that time, the major smart meter manufacturers decided to get together under a unique body to be able to come up with a standardized answer on how they would propose solution for basically developing manufacturing and afterwards deploying the smart metering across Europe.
So Sergio, the acronym DLMS, what does that stand for, and when was the organization actually created?
So the organization was created in 1991, and the acronym is an acronym for the data exchange standards, but effectively it's an acronym that, let me say that we don't use anymore into our communication. And the reason is that at the very early stage when DLMS was created, it was perceived as a communication protocol, which in fact it is not. And here we need to make the difference between a communication protocol that is basically the standardization on how you are transporting data from one side to another side, by opposition to a data exchange protocol, which is usually agnostic to any communication protocol. And the data exchange protocol is how you are formatting the data and how data are basically formatted into an adapted way to respond as best on how they are used within certain applications. And this is what DLMS is effectively. So DLMS is a data exchange protocol that is being standardized for being used within the energy industry, and it is agnostic to any communication protocol. However, this agnosticism doesn't mean that we cannot coexist with a different type of communication protocol. This is why DLMS, over the years, we have been signing liaisons with several standardization organizations that are standardizing communication protocol, such as WISON, LoRa, G3 Alliance, and so forth. And thanks to the liaison we have, we guarantee that whenever we need to develop appropriate interfaces between our standard and their standard to be able to sit on top of their communication protocol into the most optimized way, then we are doing this work together in alignment with the objective of both organizations, the organization standardizing the communication protocol and DLMS standardizing the data exchange protocol.
For some of our listeners who may not be so aware of the difference between different protocols and standards, would it be correct to say that DLMS is an application layer standard at the top of the 7-layer OSI interoperability model?
Absolutely. That is absolutely correct. So what we are doing basically, DLMS is an object-based protocol, and what we are doing, we are defining objects and classes in delivering certain functions. And then those functions are aggregated and parameterized into use cases, those use cases being application specific for different type of applications. And of course, obviously, the first one where it has been used into has been the smart metering. And into the smart metering, you do have a certain number of functions which are dedicated to measure a certain number of parameters, like the average power consumptions, or if you are measuring the reactive power and so forth. And then as you are using those defined functions, and as you are configuring them within a certain specific use case and aggregating those functions to fulfill the requirement of use cases, then these use cases are basically responding to what within a given application or on how within a given application a device should behave.
So, Sergio, for our audience, I'd like to just touch a little bit on the 7-layer OSI model. The way I think about it in a very pedestrian, simple way is that there are 7 layers, and there's a lot of engineering granularity there. But at the lowest level, I think about it very simply that the plug must physically match. The connector must be the right size, whether it be USB or Ethernet or something else. And at the highest level, it really is an application layer, which is beyond the protocol. And for those who are not, well versed in this, I often think, that languages, English, Italian, French, Spanish, they all use basically the same character set. But it doesn't mean I can understand someone who speaks another language. That language is the application layer in that world. So is that a relatively simple representation?
Okay, let me give you a good example, because as I said, I am coming from the PC industry, and I have been at the very early stage a contributor to the standardization of USB and as well Bluetooth Low Energy. And the good example is the following. When you do have a USB peripheral and you connect it on your PC, the first thing it does is that your peripheral will basically enumerate itself in saying, I am this peripheral, I am capable of doing this and that. This is happening at the low-level protocol, which is really the communication protocol between your PC and then your peripheral. But then comes the second level, which is at the level of the data exchange. And probably the old people remember when we were having the Windows 10 and before even Windows 10, that sometime when we were plugging in a USB peripheral, because the driver of that peripheral was not correctly loaded on Windows, your device was not recognized. While your device was connected and from a communication viewpoint, it was recognized, it was not behaving under the Windows application because the Windows driver were missing. This is exactly this seventh layer we are talking about.
Fascinating. That's a great example. Getting more granular and more focused. So, I heard you say functions many times. Is the DLMS standardization effort, does it focus on functional profiles for all the different terminal devices that may be on the grid? Or is it just smart meters, or can you just describe that ecosystem?
Okay, so initially, as I said, it was developed for smart metering. Okay, that is where DLMS is coming from. However, since I joined into DLMS and with the experience I brought into this ecosystem coming from the PC, in the PC and into the IT industry, we used to talk about compatibility. In this ecosystem of energy, they used to talk about interoperability. Now, it doesn't mean that because you are interoperable, that you are compatible. You can be interoperable because at the end, the data you are delivering do have the same meaning. However, in the device itself, how you are producing the data, how you are formatting the data, and how you are delivering the data into the system can be different from one manufacturer to another manufacturer. And here then is where we used to be in DLMS before. It was that DLMS was guaranteeing the certification for compliance. Therefore, we were guaranteeing that the data delivered by the devices, they were compliant according to the DLMS specification. It means they were having the same meaning. But this is not enough, because a public utility, when a public utility, they have to buy product from the different manufacturers. They would like to be able to exchange a device A with a device B coming from the two different manufacturers. In order to be able to achieve that, you got to bring this level of interoperability from the compliance up to the compatibility. And to answer now your question is that if you want to go up to this level, you cannot only implement the standard anymore. What you have to do, you have to implement it, configured and parameterized in a very specific way that you are standardizing. And as you are doing that, you are basically creating a kind of silo of functionalities which are parameterized in a very specific way, so that whenever you choose the device A or the device B, it will behave for what it has been standardized and for what it has been certified compatible. It will behave exactly in the same way. This is when we are talking about plug and play.
Well understood here. I know that some of our listeners come from the intelligent transportation systems world, where the U.S. Department of Transportation, starting 25 years ago, started a similar effort, where for a traffic signal, a call box, a toll booth, they have an unambiguous SNMP MIB, a management information base, that has the parameters in only one correct order. Each parameter has engineering units and has a legal range. And thus, if you'd like to purchase a traffic signal, you could buy it from many different vendors, but they all look exactly the same on the network. You don't really care who it comes from.
Exactly. And I think that these points, I think, is extremely important. Public utilities, when they are buying equipment, and if we start with smart meter, and we can discuss later on about other products, they are making investment for decades. And the problem is that if you are buying product from two manufacturers, today you get full satisfaction. You have two sources, it's okay. But who guarantees you that in 10 years from now, you're going to continue to have two manufacturers that are going to be there? The industry is the industry. And there are companies that are selling divisions, buying divisions, and even companies disappearing from the business and so forth. Therefore, how do you guarantee that you can maintain over these 15, 20, 25 years your investment? And the only way you can achieve that is through the compatibility. And the compatibility gives you another guarantee. It is that when you are developing compatible products, over time, you have the obligation of the backward compatibility. Over time, you can add functionalities, but the older functionalities which were existing in older version of your standard, they will have to continue to be supported exactly in the same way. And this backward compatibility is another element that is extremely important for public utility to guarantee them the sustainability of their business over a so long time.
Yes, I mean, I might also add, and actually I'd be interested in your comments on, once you have a standardized interoperable solution, that drives commoditization and prices, costing of the components does in fact lessen, ideally.
Yes, but, and here I have a good example. If you take, again, USB. When we decided to launch USB at the beginning, if I'm taking the example for the mice, at the beginning it was launched with the support of the mouse for two buttons. There wasn't the wheel. The roller was not supported. And the reason is that there were two manufacturers which were on the market with a roller, but each one, they were enabling the roller functionalities with proprietary drivers sitting on top of the Windows driver. Then it lasted for a couple of years. And then we realized that this functionality was not perceived anymore as innovation or added value. It was perceived as a normal functionality. Everybody buying a mouse, they were expecting to buy it with a roller. And therefore, what was at a given time considered innovation or a market differentiator at the level of the manufacturers, it did become general purpose, and then it becomes part of the basic driver or the basic standard. What is the lesson of that? It is that it is not because you are standardizing that it prevents you to add innovation, and it is not because you are innovating with some specific proprietary functionalities that those over time cannot become general purpose and become part of the core specification that will be basically used by everybody. So this is, I would say, the cherry on the cake for the market leaders, who are those that are driving the innovation in the market. The standardization do not stop the business development. The standardization reduce development costs, because by developing one single platform, you can touch much more, many more markets and customers than you used to do with proprietary solution. the maintenance over time is going to cost you much less as well. And in fine, what is also very interesting, it is your time to market. Because when you are developing a platform, over time, the time to market to develop instantiations of different products implementing the same platform is going to be shortened. And this is a terrific advantage for the manufacturers as well. Nothing prevents you to add the value and differentiate yourself. And this is very important.
Wow, that's great. So DLMS started with smart meters.
Yeah.
What other applications are supported today or are under consideration?
So DLMS, as I said, started at the end of the 90s. And if we look who is today DLMS, we are representing 310 members across the world from more than 60 countries. We have developed more than 300 million of product across the world. And we do have, as an example, a penetration in Europe of more than 80%. In the United States, more than 40%. Globally in Europe, we do have a penetration of 60%. Therefore, de facto, DLMS is the reference for this market. But here we are talking about the electricity smart metering. Mm-hmm. However, over those years, DLMS has been also having some opportunity of developing itself into other smart metering industries, in particular the gas and the water. If we look at those two areas, interestingly to mention that those two areas, the water and the gas, while from a metrology viewpoint, those are standardized, and ISO is doing the standardization of the metrology part. From the data exchange protocol, there are no standards covering them. So each manufacturer, they were going with their own solution. Mm-hmm. There is a European initiative that has been undertaken in the last years, which is the beginning of a kind of a standardization, but is mainly Europe specific, and that is the M-Bus with their wireless version of the wireless M-Bus. But it touched only Europe. And therefore, what DLMS have decided to standardize as well the water and the gas smart metering. And this is what we are currently doing. By the end of this year, we are going to publish the standards for the water and the gas as well. Now, of course, here we are still, even though we go into the multi-utility area, which is the gas, the water, and the electricity, we still speak about smart metering. But now comes a very interesting discussion we had internally in DLMS a few years ago, which is, okay, we are de facto the standard for the regulated world, where we are measuring those data, transforming them into a digital format, and moving them up to the head-end system. Mm-hmm. Now we know that the other side of the non-regulated world is an ecosystem that is potentially candidates to consume those data, and using those data could make value, because you can achieve a certain level of performances that will help you basically to work in a more efficient way. I'm giving you an example. In your home, you have a smart meter. Now, we have been used that when you plug the plug on the wall, you get the electricity, and the electricity is coming. But in a certain number of applications nowadays, do you really need to have the electricity now, or can you wait a little bit? As an example, if you are coming at home at 5 o'clock in the afternoon, and you will take your car back tomorrow morning at 6 o'clock, do you really need the battery to start charging at 5 o'clock? Would that make a big difference for you if this battery starts to charge at midnight while you still have the guarantee that at 6 o'clock in the morning your car is fully charged? Of course not. It wouldn't make any difference for the consumer. But for the public utility and the DSO, it will make a huge difference, because then the demand to charge the car, the battery car, you will take it out from the peak demand, which is something that is already existing today, even though we are not charging cars. And it is existing since several years. Since the electricity is existing, there are known peaks which are the beginning in the morning and the end of the day. And, we need to be able to coexist with those peaks. And the only way you can coexist with those peaks, it is to be able to understand what is the demand that is going to come and how you can still offer the energy required by this demand, however, without making your peak problem becoming even bigger, but trying to smooth this demand and to smooth it out so that you are still giving satisfaction to the consumer without creating additional problem on the grid. And here, the best example is that your smart meter knows exactly what is your organic consumption you have in your premise. And therefore, connecting the smart meter directly with the EV charger, you can tell to the EV charger how much it can demand. And therefore, at that point in time, your EV charger can adjust its demand. If you are saying to your EV charger, hey, I am sorry, I cannot give to you now anything. Please come back to me and ask me the electricity within 3 hours, it works as well, right? So these are the type of data exchange that you can enable between different type of devices, so that you can enable one device that is the one demanding the energy to adapt its demand in function of the grid, I would say, constraints that the DSO is facing. But then comes the problem. How can two devices talk to each other? Well, if they are compatible. And this is where DLMS comes into the game.
That's fascinating. And you did read my leading questions there, because I was thinking of, the world is moving to almost a peer-to-peer network of energy creation and distribution. And I was thinking about 3 or 4 applications: EV charging, energy storage, home PV or facility photovoltaic power, and of course wind. And I was thinking, where does DLMS play a role here? Are your functional profiles in the meter, or are they perhaps in some of those terminal devices?
So we have recently released the generic, what we call those instantiations of our standard parameterized and configured for a very specific application, is what DLMS is calling the generic companion profiles. Okay. And we have been releasing the electrical vehicle charging station generic companion profile a few weeks ago. So this is the first time that DLMS goes on the other side of the fence in releasing an instantiation of its protocol to permit EV chargers to connect with smart meters and take advantage of smart meter data to adjust their demand. So this is the first time. Of course, DLMS intention is not to stay there. Now, when I am saying this, there will be some market leaders in the domotic that are going to, start to scream and say, sure, but hey guys, we don't need DLMS. We have already, hundreds of other protocols. Why are you deciding to come into this area. No, that's not DLMS intention. We will only focus on the 20% of the, I would say, appliances or general product consuming electricity, on these 20% that are creating the 80% of the problem to the public utilities. And therefore, what are we talking about? We are talking about EV chargers, we are talking about HVAC heat pumps, and we are talking about distributed energy resources. Let's talk a little bit about distributed energy resources. Today, you have the photovoltaic panels, and those photovoltaic panels do have inverters. Those inverters are injecting their energy into the grid, right? And people can get advantage because they can get some money back from the energy they are selling. Well, this is great, but if you do have a big farm that is producing megawatts, these guys, they have already been discussing the project with the public utilities and how this should be integrated into the grid. So here, DLMS have nothing to say, and this is not our world. But the problem is coming from public utilities, from each one of the consumer that has 50 square meter, 100 square meter, 200 square meters of panels on the roof. This is where the problem is coming from. Those inverters, they are converting DC current, which is what the panels are producing, into AC current. And this conversion is a conversion that is producing harmonics due to the technology used to produce the sinusoidal curve. And those harmonics are injected as well into the grid. But the inconvenience is that those harmonics are pure reactive power. And when we talk to public utility about reactive power, they start to dress their hair on the head, because this means pure losses, pure money that is wasted. And therefore here comes, how can we still enable to the consumer to take advantage of the energy she or he is producing and get some money back? How can we enable that without penalizing the public utilities? Because these guys, as they are all aggregated, they will produce additional losses because of the reactive power. And therefore, all those topics need to be understood. They need to be discussed. And this is also where now comes the activity that the DLMS is doing, is that, of course, we have many members in our association. We do have different type of manufacturers. We do have public utilities. We do have DSOs. But if we want to be able to integrate with the smart meter or integrate it into the grid an inverter, we need to have the right people around the table. If we don't have inverter manufacturers that are sitting around the table with the guys producing the smart meter and the public utilities in fine facing the problem, we will never address this. And therefore, this is also what the DLMS is doing now since more than a year. We are working to have those other device manufacturers to give them some interest and try to capture their interest, to tell them, hey guys, come into DLMS, sit around the table with us, and then all together we will come up with a standard that makes the consensus in the industry. And this is very important. One thing to mention is that DLMS, as I said, is a private standardization association. But this industry, the energy industry, the water industry, is mainly relying to international standardization bodies. So we are talking about IEC, we are talking about ANSI, and therefore DLMS had to collaborate with those international standardization bodies. And this is what we have been doing in DLMS. we have been signing liaison with those standardization bodies so that they are adopting our specification and making it become part of their standard portfolio. And therefore, DLMS, in fact, is behind the curtain doing this standardization work. And once we are more or less done, then we are, of course, giving it to our members, but pushing it into those international standardization bodies for all the others that may not want necessarily to be DLMS members, so that they can take advantage of those standards published by those other international and recognized standardization bodies. So this is how DLMS is collaborating. However, DLMS, with its own activities, remain the guardian of the compliance and compatibility against the standard, whether it is published by DLMS or whether it is published by those international standardization body, because we guarantee the certification of the devices.
Great. So, Sergio, I understand, and I heard loud and clear that there are, three, call them, up and coming or current areas of interest: support of heat pumps, support of EV chargers, support of off-grid generation, wind and solar. And I believe I understand that DLMS focuses on a functional profile for applications.
Yes.
So when you have let's say the electric vehicle charger, because that example comes to mind, isn't it a challenge to have individual drivers, proprietary drivers for each supplier of inverter or heat pump? Or are you seeing more of a movement that I guess is happening in the EV charger world with standards like OCPP 2.0? Are you supporting one particular communication and functional profile for each of those devices, or do you have to write all your own drivers?
So, first of all, what DLMS is doing is always standardizing how those devices do integrate into the grid. What does it mean? Everything which has been standardized by the electromobility ecosystem, which is the connectivity of the car and everything that is being done by OCPP and so forth, this is not our world. We are not putting our hands into this landscape. What we are enabling, it is the connectivity between the EV charger and the smart meter, which does not exist, which nobody today have been standardizing. This is so basically we are filling this gap. Mm-hmm. Because if we don't do that, the only way you would be able to integrate, as an example, an EV charger into the demand response would be from the top, by having the demand response aggregator that will share the data with the public utility and understand how they can use those data. But you know what? While this could be working, it's a cumbersome path you are taking. Why do you want to bring up the data from the smart meter and then pass them on the other side and then take them down into the EV charger, while you do have the two devices which are sitting one next to the other one 10 meters away? It doesn't make sense. It doesn't make sense from how much it will cost to everybody to transport those data, how difficult it's going to be to manage this data transportation and sharing those data, because of the different type of ontology that each one of the other worlds they have decided to use and so forth. It will be much better to do this data exchange locally at the level of the edge. So then this is what we are talking about, data sharing at the edge. This it is what it is about. This is exactly what it is. Sharing data at the level of the edge. Now, DLMS, of course, is one. But do we pretend that all those devices are going to speak DLMS? Of course not. I mean, we are not naive to think that everybody, all the manufacturer of the EV charger, they are going to implement the DLMS. That will never happen. There will be people that will have an energy management system which will connect with, I don't know, Matter, and will drive the EV charger via Matter. Therefore, is the end of the game? No. What DLMS is doing then, what we will do, we will expose those data via a dedicated generic companion profile, and if needed, we will map those data against those other protocols which we believe are those that are the most relevant. The only difference, if we do that, is that because we are exposing the data and we are mapping the data, we guarantee the cybersecurity of the grid. Because the grid is a strategic infrastructure, and we should not open the door to anybody to come into the grid in a way and in another, because the more devices will connect to the grid, the more application will connect to the grid, the higher the cybersecurity is going to be.
Yes. This has been a tremendous discussion so far. Let me ask you, what challenges does DLMS face in the future or today in gas and electric and water?
Let's say that historically those industries are industries which are, as I said at the beginning, highly regulated, and most of the time the key players that nowadays are private companies, they are privatized companies. They used to be government companies. And therefore, the mindset of these companies is really slow moving. And because it is slow moving, it is, on one side, it is a certain advantage, because when you are making investment of 10 years, 15 years, 20 years, better you are slow moving and you think well what you are doing. But on the other side, it is in contradiction with the evolution of the telecommunication technologies and with the data exchange technologies and the capabilities on doing data analytics. And here, the difficulties that DLMS is facing today is how can you reconcile this mindset of slow movers with the needs of the telecommunication technologies and the data analytics that is working with a tempo that is completely different. How can you reconcile the two together? This is the main difficulties that DLMS is facing today. But guess what? I mean, we are really those that are bridging these two worlds. So if we don't do the job, nobody else is going to do it, right? So we have
exactly. So what do you see for the future for DLMS?
Well, that's a tough question. Depends how many years I'm going to continue to remain in DLMS. So that would be the difference between a short time and a long time. No, definitely, as I said, I've been having a unique experience with USB and with Bluetooth Low Energy. I do remember at the beginning in the Bluetooth world, the Bluetooth was developed by the telco companies, Nokia, Ericsson, Motorola. These were the guys that were developing, that did develop Bluetooth for the mobile telephony. And when we started to have the discussion with these guys, they wanted to enter into the PC landscape. But at that time, Bluetooth was done and conceived by the people which were coming from this industry, which means they were used to have a mobile phone and you are charging the mobile phone every single day. Now, if you take this technology, which was the Bluetooth one, and you put it into the PC ecosystem, can you ask people to charge a mouse, a headset, or a headphone every single day? This is what we used to do at the very early stage. But it's from a usage viewpoint, a usage model viewpoint, it doesn't work. And therefore, we changed and we worked together to adapt the technology evolution to the usage model which were the one foreseen into the PC or the consumer electronic. And look at today. So we finalized this, it was 2005, and today we are more or less 20 years after, and we have more than 5 billion of devices installed around the world that people don't care anymore. They buy a headset, they buy a headphone, they buy a boomer speaker, they connect it, it works seamless, no brainer, So, of course, DLMS is not touching this consumer ecosystem, but up to a certain extent, I'm asking myself the question, why would this not be possible in the energy landscape? There are no reason. The technology are there, the competencies are there, and the market leaders, those who are making the market happening, are there as well. The only thing that is eventually something that can trigger this to happen, it is really to change the paradigm of the standardization. Instead of standardizing business that you have created, you innovate through this standardization. And this is what makes the big difference. When we started USB, when we started Bluetooth, we started with a white page. Nothing was existing. And we said, okay, this is the market we have. This is where it is today. This is where we want to go tomorrow. How can we go there with a standard? Not with a technology, with a standard. And we defined the standard. Then people developed the technologies, they implemented this standard into different types of technologies, and you see the result today. So I believe that this is feasible as well into the energy and water ecosystem. So my dream is to see maybe in 5 years from now or 10 years from now, this plug-and-play connectivity that can occur with, an EV charger. If you go into Best Buy and you buy an EV charger, that is a consumer appliance, you buy it, you don't care anymore. You connect it to your smart meter and it does the job, And so this is what is my dream. Are we going to be able to get there? I don't see why we shouldn't be able to get there. I think that if people want, we can make it happen.
That's fascinating. And actually, Sergio, this has been the entire almost hour we've had here has been very fascinating. In our last few minutes left, what advice do you have for industry peers, for other users? What closing thoughts might you have for our audience today?
Well, what I would recommend to the people is don't be scared by standards, and don't believe that standards are activities done by old birded engineers that are almost in the garage track. That is not what it is. Standards, innovation can coexist and can exist through standards. So I am really encouraging also the young people that are in the university doing research, that are in the startups, do not hesitate. Come with your ideas into the standardization bodies, and because of the power the standardization body has to influence the market, your idea can even become bigger thanks to these standardization efforts. So I would really encourage people to come into the standardization bodies and be active, participate to the standardization. If you are around the table, then you can influence how the standard is developed. If you are not around the table, you have nothing to say. Take it or leave it.
That's great. Sergio, thank you again. This has been really, truly just a thought-provoking and very insightful hour that we've spent together. Lastly, for our audience, if they would like to reach out and contact you, how do they find you on the internet?
Well, you can go into the LinkedIn, and there is the DLMS page. You can go to the DLMS page. Or personally, myself, I am as well on the internet. You can contact me on LinkedIn as well, or on the DLMS website, dlms.com. You can go there. You can get in touch with the different. Also, if you wish to subscribe, become a member, or if you wish as well to have answers to certain questions, feel free to contact the people via the DLMS website. There are the different addresses. There are also the chairman and the secretary of the different working group can be touched into the DLMS website. And I would really encourage the people to go and see what DLMS is doing on our website to understand what we are doing.
Well, once again, audience, our guest today has been Sergio Lazzarotto of the DLMS User Association. Thank you, Sergio.
Thank you very much for having invited me.
It's our pleasure. We hope to see you again when you have some additional developments in the next few weeks and months. And we look forward to our audience again on the next episode of the Sustainability Podcast. Thank you for joining us today.
Thank you very much.